that would give me y equals x plus 1. Or I can pick a negative line. There's all kinds of things I can do. I go with a parabola. I could make a parabola where that's the vertex. So that would be the easiest one. And all I'm going to do is think about the y equals x squared equation. And I'm going to shift it over 2 and up 3. So to do that, I've got y equals, I'm doing this parabola one now. Kind of running out of room up there. Y equals, to shift it to the right 2, I have to subtract 2 from the x. And that's my squared. And then up 3, just a plus 3. And then the vertex of that parabola will hit right at that point 2, 3. Again, that's your advanced algebra stuff coming into play. Okay, so did I need to do 3 equations there? No, you only needed 1. Sketch and write an equation that satisfies the condition. Okay, let's try a little more challenging one. Same problem. Sketch and write an equation. This time your function has a limit as x approaches 2. Remember, that just means your 2 fingers have to come together at the same spot. It's not continuous. At x equals 2. So that means we're going to have to put a hole in this graph. So here we go. Here. So here's x equals 2. I don't care what the y is. It didn't say anything about what the limit had to be, what I had to approach. So if I just say it's going to approach 2, I'm going to put the hole in the graph right there. Actually, no, I'm going to make that 1. Oh, 2 2's in the problem. So that's at 2, that's at 1. Okay, I'm going to stick with a linear function. I'm going to make it go through the origin. Okay, to write the equation of this line, it is not difficult. You just pretend that that was just filled in completely. Pretend that the hole is not even there. To write the equation of that line, you need the slope and the y-intercept. Well, my y-intercept I chose 0, so my b equals 0. My slope, I'm going to rise 1, run 2 to that point there, if that was filled in. So my slope is a half. So the equation would be y equals 1/2 x plus the 0. To put the hole in there, all I've got to do is have that factor of, in the denominator, I've got to have, when I put the 2 in, I want it to be 0. So that means this would have to be x minus 2, because 2 minus 2 is what's going to give me the 0 down here, which is going to give me the hole. And in the top, I just have to have the same factor. That makes it a removable discontinuity, and it would give me the solid line. But by having that there, if you were to look at your table of values, you're going to have all of these y values except for an error here when x is 2 because of this canceling out factor. And what you'd be left with is your line, 1/2 x. Okay? Horizontal line. Okay, that's going through 1. So the equation would be y equals 1. But then to put that hole in there, same thing. To put the hole in, I just need that factor that cancels out, and it has to make the denominator be 0 to give me that hole. Those would cancel, you're left with that 1. I could do the same thing with my parabola again. Okay, the equation of that parabola would be y equals x, and I went over 2, so minus 2 squared, up 1. But then I've got to take that and multiply it by that x minus 2 over x minus 2 to get the hole in the graph. Without this being there, all you get is a solid continuous parabola, but I wanted it not continuous at 2. So there's 3 equations there. You do not need all of them. Okay. if f of x is this piecewise function where we've got ax cubed if x is less than 2 or equal to 2, and then the function equals b times x minus 3 squared plus 10 if x is greater than 2. So for this part of the graph, we've got a cubic, and then for this part of the graph, we have a quadratic. So what we want to do is, what are the directions here? I think find values for a and b to make the graph continuous and differentiable. So find a and b to make f of x continuous and differentiable at the break here, at the break in the domain. At x equals 2. So think of this as two separate equations. Let y1 equal ax cubed, and let y2 equal b times x minus 3 squared plus 10. Okay, so to be continuous, that means that they have to have the same y value when x equals 2. So the first thing you want to do is just set them equal. Set y1 equal to y2 to make them continuous. Let's see, at x equals 2 for continuity. Then you're going to set the derivatives equal at x equals 2 for differentiable. Okay, so here we go. So setting them equal, I have ax cubed equals b times x minus 3 squared plus 10. And I know that x is 2 in this problem because that's the break. So if I put 2 in here, that's going to give me 2 cubed is 8a. 2 minus 3 is negative 1. Negative 1 squared. I better write that out, I'll never remember. So I've got 8a equal, that'll be negative 1b plus 10. Okay, now we ran into a brick wall. I've got one equation with two unknowns in it. That's impossible to solve. I need a second equation to solve this. That's where this derivatives being equal is going to give us a whole different, two different equations that we can work with and solve it as a system. Okay, so that's what we'll do next. We'll do the derivative. So the derivative here, remember a is going to be a constant. It's like a multiplier. It's like a 5 sitting there. So the 3 comes down, gets multiplied by this constant. That'll be 3a. X to the 1 less power equals, here, remember that's like a 5 or a 6 or whatever. It's a constant. Treat it as a constant. So we've got inside, outside. So the 2 comes down, 2b times x minus 3 to the 1 less power, so to the first. The inside derivative, derivative of x is 1. Not that I need that. Plus the derivative of 10, that's a constant, that's 0. So I don't need that. And now I can put the 2 back in for the x here also. So that's going to give me, if I put a 2 here, 2 squared is 4, 12a equals 2b, 2 minus 3. That all goes away. So this is going to turn into negative 2b. So I've got two equations with two unknowns. I think I'd like to do this one with substitution. If I solve this one for b, get it b equals, I can substitute it in here. So all I've got to do is divide by negative 2. I usually do linear combination, but I think this one's set up nicely for substitution. This will give us a negative 6a. So now I can take this, substitute it in for the b, and I'll have 8a equals negative 6a plus 10. Now I've got one equation with one unknown that can be solved. So add 6a to this side, that'll give me 14a equals 10. Divide by 14. Kind of running out of room here. 5/7. Ooh, that's what I got in my notes. That's good. And now I've just got to find the b, and I think this is going to be the quickest spot to figure out the b. So if I put the 5/7 back in here, and it can go anywhere in any of these equations to figure out the b. I think this is just the quickest one. So b will equal negative 6 times 5/7, negative 37. So there's my 2. So lots of algebra stuff going on in there, but I think you can handle it. All right, your homework on this part of the section 6 is page 157. Let's go quickies 1 through 9 odd, all of 1 through 20, and then 21, 25, 29, 31. I think I only gave you one of these ones like the last one I just did. We'll save most of those for tomorrow. Give you a little practice today. And that's it.